Welcome back to Algebra 1, Topic 30, Scientific Notation. In this video, we will practice evaluating in scientific notation. What I first want to remember is the properties of exponents because they will come back and they will come in handy again. So looking at this problem, what do we notice first? We have 4.6 times 10 to the third plus 8.72 times 10 to the third. So looking at this problem, we know that we're dealing with addition here. And we also know that they're both raised to 10 to the third power. So these two powers of 10 have to match in order to add or subtract them. And because they match, we can do something like the distributive property, my favorite property, but the opposite. So what we're going to be doing here is kind of like factoring, which we will learn later in the year, but it's basically the opposite of the distributive property. We are undistributing. So because we notice that we have times 10 to the third here and here in both quantities, we can take it out and rewrite it. Then what I want us to focus on is our numbers right here. So 4.6 plus 8.72. And here, if we wanted to check our work, we could distribute back this times 10 to the third into both quantities, and we would end up getting our example listed right above. So we're going to focus on PEMDAS right now, and we're going to evaluate. Okay, what's 4.6 plus 8.72? So I'm going to go to my calculator. 4.6 plus 8.72 gives us 13.32. Times 10 to the third. Bring that right down. Now am I done? Remember, if I want my answer written in scientific notation, I need to have just one digit in front of the decimal place. Here, I have 2. So I need to take my decimal and move it 1 unit over to the left. So my new number, I'll get 1.332 times 10 to the, I don't know. So personally, what I like to do here is think about this. If I have my number, if I have my number 13.32 and I'm multiplying it by 10 to the third power, that means I'm moving my decimal place 1, 2, 3 spots to the right, and I'll put a 0 where I don't have any numbers. Now, if I have my value 1.332, and I also want to end up with a 0 at the end, how many spaces do I need to move my decimal? I need to move it 1, 2, 3, 4. So my exponent is going to be to the 4th power. And that is my answer. 1.332 or 1 332 thousandths times 10 to the 4th power. Now, sometimes in problems, if you want to add or subtract numbers written in scientific notation, but they have different powers of 10, we first need to change or rewrite the numbers so that they have the same powers of 10. So what we're going to do here is we're going to convert. So I know, looking at my example, I'm dealing with subtraction now. So they have to match. But if I look at my exponents, I have 10 to the negative second power and 10 to the negative third power. So if I wanted to rewrite this, I need to decide, okay, which quantity do I want to change? Well, let's change so they're both in terms of times 10 to the negative second power. It technically doesn't matter, but for this example here, we'll do it. So I want to change this quantity. So if I have 6.6 times 10 to the negative third, and I want to change it so I have something times 10 to the negative second, so that way the quantities match. So what I like to do is if I have 6.6 times 10 to the negative third, if I move my decimal place, this is telling me that the number that I'm dealing with, if I move it to the left 1, 2, 3 spots, is 0.0066. Now my new number deals with times 10 to the negative 2. So if I take my number here, where my decimal place is, and move it 2 spots back, that will refer to my new number with my times 10 to the negative second power. So the new number that I'm dealing with is 0.66. And we can double check that. If I have 0.66 times 10 to the negative second power, will that give me the same original answer? Let's try. So if I have times 10 to the negative second power, I'm going to move my decimal place over 1, 2 spots, so I get 2 zeros there. And the two quantities match, so I'm all set. Okay, now let's actually go into evaluating this problem. So we have 3.5 times 10 to the negative second power minus 0.66 times 10 to the negative second power. Now, since these two quantities match, I can undistribute and write them out here. And I just want to focus on my two values here. So 3.5 minus 0.66. And I'm going to evaluate that. So 3.5 minus 0.66 gets us 2.84. And then bring down my power times 10 to the negative second power. Now, am I done? Well, I only have one digit in front of my decimal place. So I am all set, and my answer is in scientific notation. Moving on to the next problem, here I'm dealing with multiplication. So I have my parentheses right here. So problems involving multiplication or division do not need to have the same powers of 10. So notice my powers here. I have times 10 to the second power and times 10 to the sixth power. So if I want to simplify this, I can regroup. Because multiplication is both commutative and associative, I can regroup these values together. So I'm going to regroup my numbers together. 8.5 times 1.7 and multiply that by 10 to the second power times 10 to the sixth power. Now remember when I said to think back to those properties of exponents? It's because they come in handy here. Okay, so let's write my answer. Let's focus on the blue part right here. 8.5 times 1.7. So 8.5 times 1.7. That gives me 14.45. Now the powers of 10, on the other hand, here, notice how I have the same bases, and I am multiplying. So because I have the same bases and I'm multiplying, what do I do with my exponents? I add them. So I get times 10 to the 2 plus 6, which gives to the 8th power. So I have 14.45 times 10 to the 8th power. Now here, is this answer written in scientific notation? No, it is not. So I need to move my decimal one spot over. Now we can use the methods that we've been doing for addition and subtraction in order to determine what my new exponent would be. So I would have 1.445 times 10 to the 8th. We can think about it. In this problem, if I originally had my decimal point here, I would need to move my decimal over 8 spots. But if I take a step to the left, if I wanted to move my decimal place over, that means I'd have to move it over one more spot. So my new exponent isn't going to be 8, it's going to be 9. Moving on to the last problem, 1.5 times 10 to the negative 8th power divided by 6 times 10 to the 7th power. And I want to write my answer in scientific notation. Here we're dealing with division. So I'm going to regroup this just like I did with multiplication. So I'm going to have my 1.5 divided by 6. I'm going to regroup those numbers together. Times 10 to the negative 8th divided by 10 to the 7th. So I can simplify this. 1.5 divided by 6. What does that give me? 0.25, or 25 hundredths, or a quarter. Now 10 to the negative 8th divided by 10 to the 7th. Because they have the same bases, what I'm going to do with my exponents is subtract them. So I'll get times 10 to the negative 8 minus 7, which gets me 0.25 times 10 to the negative 15th power. Now here, I want to look at my answer. Am I done? Is it in scientific notation? Notice how I have a number in front of the decimal place, but it's 0. It's not a number that is 1 or greater but less than 10. 0 is not included in that range. So I need to move my decimal place over 1. So my new number would be 2.5 times 10 to some power. So if we think about, again, moving our decimal place, if we have 0.25 times 10 to the negative 15th power, I would need to move my decimal place over to the left because it's a negative exponent 15 times, and so on and so forth. However, if I move my decimal place one more over to the right, how many spots total would I need to move my decimal place so that I would end up having the same value in the end? Instead of moving 15 spots to the left, I would need to move 16. So my new answer is 2.5 times 10 to the negative 16th power. And that is it. Thank you for watching.